Hello everybody, this is Ryan with Over Technified. Today I'm working on my Magnum 360 build. It's going into my 1999 Dodge Durango. It's my off-roading rig. I'm really excited to have this brand new torque converter from Hughes Performance. Had this thing custom made, spec'd out for the vehicle, so that's pretty awesome. I specifically wanted a torque converter with this billet back, so I'm really excited to have this thing. There is a problem with this torque converter, however. It's not really with this torque converter. I'm sure this thing is great. I haven't tried it yet, obviously. But the problem is the fact that it is a billet back. It does not work with the stock Flexplate. The stock torque converter has these mounting pads on it. So I don't know if you can see there is space between each mounting pads where the plate goes in, and on the converter there's counterweights. So I'll show you. This is the stock Flexplate. Has these counterweights here, and when it bolts up to the torque converter, you can see the counterweight is sitting between those pads. That does not work on this thing here. So if I go like so, it just doesn't go flat. That's a problem. So on the Magnum 360, it is a externally balanced engine. So these counterweights here are actually part of the balancing of the rotating assembly. So I cannot just simply knock these off. As this thing bolts up to the engine would be on this side and the torque converter on this side. I thought about taking and removing these counterweights and putting them, remounting them on this side of the plate. However, there's not enough clearance between the back of the block and the flex plate. So that unfortunately will not work. So anyway, I was talking to Hughes Performance. There's some really good folks there. They've been extremely helpful. So although I haven't tried the converter itself, I can say that their customer service is really good, and I really appreciate those guys. They actually sent me to help resolve this issue a brand new flex plate here. Yeah, they really took care of me on this. This is a cool flex plate. It's got a half moon cutout, which makes this side heavier, just like this plate has a added weight here. This plate actually subtracts weight on one side, so that's how the balancing on this flex plate works. This thing will bolt up to this torque converter, so that's cool. However, what this flex plate lacks is a tone ring for the crankshaft sensor. I'm running the stock PCM, and I need this original crankshaft sensor to work because I'm not running a carburetor. I'm keeping the fuel injection, all that. So what I have to do is take this flex plate and cut off the tone ring and then weld this ring to this flex plate somehow. All right. I just got both of my flex plates back from the local fabrication shop. They did a good job. I had them take this old flex plate and cut the tone ring off of it, and then I also had them take this new flex plate and trim the diameter down so that it would fit nicely inside this tone ring. So as you may know, I'll set this aside here. As you may know, on these Mopar small blocks, the bolt pattern for the flex plate is not symmetrical. There's only one way it can bolt to the crankshaft, and so I'll demonstrate that here. If you clock it any other way, not all of the holes are going to line up. The only way that it will line up is that way. So even if you put it in reverse, there's no way it's going to line up in reverse either. So you can't get it wrong if you do it, as long as you can get it right. But you can get it right. Anyway, so it only clocks one way. So with that being said, I have to get this tone ring clocked properly on this flex plate relative to that bolt pattern. And then also the crank sensor itself is off to the side of the block, and it's spaced so far away from the block. So I have to get this ring spaced properly away from the block so that it lines up with that sensor, and that way I'll get a good signal. So once that's done, once I'm clocked and located away from the block properly, then I gotta take and weld these two together. So that is the next step in this process. All right, so I have the old flex plate bolted onto the crankshaft. These bolts are just snugged down. There's a little bit of play in the crankshaft here. So as I do this, my method is to put them in and go all the way that way, and then snug them down. That way, I'm not clocking them slightly differently when I put the other plate on here. So with that being the case, I have this wire here pointing to this notch on the tone ring. And so I'm pretty well exactly lined up. That's my location marker there for the other tone ring. And as far as how far out the tone ring goes, I have this measured so that according to the mark, I'm 3/4 of an inch out. Now it's more than 3/4 of an inch, but this thing, I have it lined up on that mark exactly. So that'll just make it easier when I get it, when I put the other plate on. So those are my two dimensions that matter. So I have my clocking marked with the wire, and I have my distance from the back of the crankshaft marked on this guy here. So now we'll swap out the plates. So I like that my mark is working on the tape, so that's cool. We check this measurement here, and it looks like I'm pretty well spot on away from the crankshaft. So I'm happy with that. Okay, I have the tone ring welded to the new flex plate, and that turned out pretty good. I want to verify right now that the crankshaft sensor is going to be properly triggered by this setup here. There's a couple reasons why it could have issues, and the first reason, one reason is the thickness of the flex plate kind of intrudes into the hole a little bit. And the other reason is the torque converter itself has a lot of metal that sits right behind the tone ring. Unlike the original stamp steel construction torque converter, where between the bolt holes is a lot of open space, and that open space tends to be where these triggering holes sit. So there's no metal behind the trigger holes on the original setup. So I want to make sure that that won't be an issue with how much metal is behind all of these trigger holes on this setup. So we'll do a little benchtop test here. So what I have is a 5-volt power supply providing the 5 volts that powers this sensor, the crankshaft sensor. I pulled this off the back of an engine, and I have a 5K resistor here, or excuse me, a 15K resistor there. So it's basically just replicating the circuit design that would be found on the vehicle as far as the crankshaft sensor is concerned. So, and you'll see it on the scope. All right, so make sure that if I take up all the slack so that there's literally no space between the tone ring and the torque converter there, we're going to try that first and make sure that we can trigger it. If I hold it right, there it is. So that is a successful test and proves that there is going to be zero problem with the torque converter being the way that it is. And it also proves that the thickness of the plate is not an issue as far as this is concerned. We will try this with the flex plate on the back of the motor mounted to the crank with the sensor on the back of the engine where it goes. All right, so now I have the flex plate mounted up. Well, it's just on the crankshaft. I've got the crankshaft sensor back where it belongs on the back of the block. I have it wired in the same way with the little 5-volt power supply and the same test circuit that replicates what the vehicle would otherwise do, and the oscilloscope right there. All right, so point of this test is to verify that when all is said and done, when the flex plate is sitting the way it's going to sit on the vehicle and the crankshaft sensor is sitting the way it's going to sit on the vehicle, that's going to work. So that's what this test is going to do. The other
thing to note is I've observed after on looking at this that as the ring goes around the plate, I got the plate itself has this half moon cut out. That's, I'll call it a negative counterweight. As the tone ring bridges across this open gap, it actually gets further away from the sensor itself, so I got to make sure that that won't be an issue. And as you can see right there, it's not. So far we have a good test. So we'll spin this around, and you can see got a good signal there on all of them. They are all working. And then when we go across this pulse point there on the open gap, it still works. And if I spin it a little faster, we can see that I am not losing any pulses. I'm not dropping signal pulses at all. So this flex plate with this tone ring is going to work. I am confident now that I will not have any problems whatsoever putting this thing in the vehicle and having it not fire up on me because this is wrong. It is in fact right. So I'm excited. This worked out well. All right. So I just wanted to show a final product. This is the new flex plate that has been turned down in diameter because it's actually wider than the old one. This is the old flex plate. So you can see the tone ring on the crankshaft position sensor. So yeah, I had another one of these that I had a local machine shop cut the tone ring off. So that is what you see there, if I can focus. Yeah, and then and again, that same machine shop took this flex plate and cut it down so that it fit inside this tone ring nicely. And then I took and welded it all up after clocking the tone ring appropriately so that each of these square holes would line up properly to the bolt pattern here so that it would run properly, have the correct ignition timing and all that. And after it was welded, I took it to my other machine shop that did the work on the block here and had them balance match it to this one, because these flex plates are counterweighted. The rotating assembly has to be balanced with the flex plates. So I took both of these flex plates after it was welded to that machine shop, and then they put this thing on the spinner, measured it, and then adjusted the balance of this one to match this, because this one was balanced with the rotating assembly in this block. So that's why you see this all cut kind of funny, because that was part of the balancing. Anyway, so that's the end product. I just wanted to kind of show it before it goes in the vehicle. I'm minutes away of getting it in there. So anyway, that's the torque converter happily in its place of home. Thanks for watching, and y'all have a good day.